Okay, now then, this question 4 here on the homework. It may be that you think, okay, if I'm using this equation, okay, then 150 is the starting amount, and you might think that 0.4 is the decay rate, and you might think that's it, but it's not going to accept that, okay? What you have to do is actually find out how much you have after 1 hour. So if we start with 150, what is 40% of that? So that is 60, okay? So if we've gone down, decays by that, if we've lost 60, then we must still have 90 in the body, okay? So this would be the equation. And again, that's after 1 hour. So take a look at this. So after 1 hour, we have 90 milligrams of the drug. We started with 150. So you're going to have to do this first, okay? Remember, that's what we've lost. So this is what we've got left. Right, now, if we divide both sides by 150, that's 0.6 equals e to just k exponent, because it's a 1. If I log both sides, remember, if we log this side, the answer is just the k. So that is the answer, and I think that comes out to negative 0.5108. Okay, that is k. So what you're going to write is this. A equals 150, because that's the starting amount, e to the negative 0.5108 t. Okay, and that's what I would put into web work. Right, if you only use the formula for 5 hours, that is 5, you would just put 5 there and work out it is. The half-life of the drug, well, remember that's going to be half equals e to the negative 0.5108 t, and you're just going to find t. Okay, again, log both sides. Right, okay, so that's that question 4 done. This question 5. Now, this is one of these logistic growth models. So, this first part, after 4 days, you just put 4 into there, put it in your calculator, okay? Now, the long run means as t goes to infinity, okay? So when it keeps on going further and further in the future, this is going to tend to 0 and vanish. That would be your answer. So that's going to be 90 days, okay? 450 divided by 5. Right, the last one in here is more like the test question. Again, we're using this equation, okay? KT. Okay, right, our initial amount is 190. In the future, it's 250. E to the k. How long did it take? It took 20 years. Okay, there we go. So, of course, I'm going to, first of all, I'm going to divide both sides by 190. So, calculator out. Cancel, right. 190 divided by 250 divided by 190, sorry. 250 divided by 190. I was staring at my calculator, not the screen. Okay, that's, let's do that again. 250 divided by 190 equals, right, 1.316, call it. 1.316 equals e to the 20k. If I log both sides, ln, don't forget, then remember, just the right-hand side is 20k. This is still ln 1.316. So if I natural log that 1.316, hit the ln, and then divide it by 20, I get, right, 0.0, I'm going to go at 14. So k equals 0.014. That's what I get for all this work. Okay? Let's erase all this now. The next part is how many in 2020. Right, if I say 2020, remember, from 1990, that's 30 years. Okay? 30 years later. So I just put 30 back into the equation. Okay, remember, k we already know, it's this. Actually, I should write this. If we want to do exponential growth, the model, this is what I should write. A equals 190 e to the 0.014 t. Okay, that's the model. So I'm just putting 30 into here. What's the doubling time? Well, this is just you doing this. Remember, 2 equals, we don't need a starting and future amount. We know it's twice the amount. Again, 0.014 t, and again I would just log both sides and take it from there. Okay, right, so that's all the application problems done.